Good afternoon, everybody. How are you all? Hope you are doing great this afternoon. So today we are going to talk about linear regression. So here I go. Linear regression, linear equations. Linear regression for two variables is based on a linear equation with one independent variable. The equation has the form y is equal to a plus bx, where a and b are constant numbers. Y is the dependent variable which depends on x, which is the independent variable. The variable x is the independent variable and y is the dependent variable. The graph of a linear equation of the form y equal to a plus bx is a straight line. That's why we call linear. It comes from the word line. The following are examples are linear equations. Y equal to 3 plus 2x. The number 3 is the intercept, okay, where the straight line cuts the y-axis. In this case, the first equation, the straight line cuts the y-axis at the point 0, 3. That is 0 because it's on the y-axis, its x-coordinate is always 0, and its y-coordinate in this case is 3. 3 is called the intercept of the line. And the coefficient of x, which is 2, is called the slope. What is slope? It's rise over run. Okay, rise over run. Okay, here the slope being 2 and positive, it's going up a steep hill. Aaron's word processing service does the word processing. The rate for services is $32 per hour plus $31.50 one-time charge. The total cost to a customer depends on the number of hours it takes to complete the job. Find the equation that expresses the total cost in terms of number of hours required to complete the job, which is y equal to the fixed cost of 31.5 plus if we employ them for x hours, it is plus 32 times x. So 31.50 is the fixed cost. Okay, it is the intercept on the y-axis where the line, straight line cuts the y-axis, and 32x, 32, the number 32 is the slope. How much does y change for 1 unit increase in x? Remember here, x is the number of word processing hours. So if x, the word processing hours increase by 1 hour, they're going to charge you $32. That is the slope. Okay. For the linear equation y equal to a plus bx, b is the slope and a is the y-intercept. From algebra, recall that the slope is a number that describes the steepness of a line. Rise over run. If your slope is positive and greater than 1, then your rise is greater than the run. And the y-intercept is the y-coordinate of the point 0, a. 0 because it's on the y-axis, x-axis, x value is always 0, where the line crosses the y. These are the graphs of y equal to a plus bx. Here, a is the intercept, b is the slope. If b is greater than 0, that is positive, that means we are going up a steep hill. If b is equal to 0, then we are on a flat line which is parallel to the y-axis, x-axis. And if b is less than 0, then we are going down the hill. Here, the rise is less than the run. So here is another problem. Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour for tutoring. A linear equation that expresses the total amount of money that Svetlana earns for each session she tutors is y is equal to 25 plus 15x. What are the dependent variable? That is the amount of money she's going to make. What is the y-intercept? Y-intercept is 25. She will charge you $25 irrespective of how many hours of tutoring she does. And what is the slope? The slope is 15x. What does slope is 15? What does it mean? It means if your X, that is the number of hours of tutoring, increases by 1 unit, your cost will go up by $15. Okay. Slope is rise over run. So if your run, that is change in X value or change in time of tutoring is 1 hour, your cost will be $15. That is your slope, okay, is 15. So scatter plot, as the name implies, it's a scatter plot, means X and Y values are scattered all over the XY coordinate system. Before we take up the discussion of linear regression and correlation, we need to examine a way to display the relation between two variables X and Y. The most common and easiest way is a scatter plot. A scatter plot shows the direction of the relationship between the variables. A clear direction happens when there is either high values of one value occurring with high values of the other variable, which is a positive slope, or low values of one variable occurs with low values of the other variable, and high values of one variable, second bullet, high values of one variable occurring with low. So as X increases, Y decreases, that is going down the hill. It has a negative slope. Okay, you can determine the strength of the relationship by looking at the scatter plot and seeing how close the points are to a line. When you look at a scatter plot, you want to notice the overall pattern and any deviations from the pattern. The following scatter plot illustrates these concepts. And the first one on the top left, you're going up the hill, almost all the points fall close to a straight line going up the hill. So it's positive slope going up the hill. Part B is similar, except there is one point which is on the top left. Okay, this seems like an outlier far away from the rest. So that is in diagram B, okay, on the top right. Diagram A in the middle, going down the hill, negative slope. As X increases, Y decreases. B in the middle, there is good scatter in the plot, but on the overall, there's a negative slope going down the hill. Okay, and the bottom one, A, is an exponential. Why it is exponential? Because the points are going up, but they're not on a straight line. They're on a curved pattern going up. And in the last one, in the bottom, extreme bottom, there is no correlation, no type of relationship between X and Y. Okay. So here they explain how to use the calculator to do a scatter plot. Later on, we will show you a problem that I worked using TI-84, which will show you how to do this. Okay. So how do you make a scatter plot out of this? In Europe and Asia, M-commerce is popular. M-commerce users have a special mobile phones that work with electronic wallets, as well as provide phone and internet services. Users can do everything from paying for parking to buying a TV set or soda, from a machine banking to checking sports scores on the internet. For years 2000 through 2004, was the relationship between the year and the number of M-commerce users. This construct a scatter plot between X is equal to the year and Y equal to number of M-commerce users in millions. So the first thing you will do, you put the calculator on, press the second button, then the plus button on the bottom right corner on top of the enter button on the bottom right. So second plus, and then number 4, type number 4. That will give you clear all list on your calculator. Hit enter. Okay. Then you will press the stat key, which is in the second row, and then number 1. In L1, you are going to press the years. Okay. So the first number you type in L1 is 2000. Then 2002. Then 2003. Then 2004. Okay, once you are done with 2004, press the right cursor key on the bottom right corner. This will move the cursor to the first line in L2, where you're going to type the Y figures, which is 0.5, then 20, then 33, then 47. Suppose I want to make a scatter plot out of this data. So in L1, I have entered X data. In L2, I have entered Y data. So I press the second button on the top left corner of the calculator, then Y equal to key on top of it. Then I press number 1, okay? Gives me plot 1. The second line should be flashing on, okay? And I want to do a scatter plot. So my type should be the first, second line type should be the first type of chart. So put your cursor on the first type of chart and hit enter. Next, you will see X list is L1, Y list is L2. Then press the zoom button, which is the third key on the extreme top row. Zoom and then 9. And you will see it's going up the hill. Okay, straight up the hill. Okay. So it's a positive relationship between years and number of M users. Here is another problem. Okay. X is hours packing jumpsuit, Y points scored in a game. Amelia plays basketball for high school. She wants to improve to play in a college level. She notices the number of points she scores in a game goes up in response to the number of hours she practices her jump shot. Okay, each week. She records the following data. Construct a scatter plot and state if Amelia thinks if what Amelia thinks appears to be true. So first I will clear the data in L1 and L2. So I press the second button on the top left corner, then the plus button on top of enter, then number 4, clear all list on my calculator screen. Then I'll press the enter button, done. Then stat 1. In L1, I'll type the X data, 5, 7, 9, 10, 11, and 12. After I'm done entering the last number 12 in L1, I'll press the right cursor key on the top right corner of the calculator. Okay, this will move the cursor, the black rectangle in the first line in L2, where I will type 15, 22, 28, 31, 33, and 36. Once I'm done with that, I'm going ready for a zoom plot. So I press second Y equal to, second button, and then Y equal to key just on top of it. Then press number 1. Okay. And first line should be on, cursor should be flashing on, second line on type, first type of chart, hit enter. X list is L1, Y list is L2. Then you press the zoom button, which is the third key on the extreme top row, zoom 9. And you will see a straight line, the points are located close to a line going up the hill. That means as X increases, that is X number of hours practicing jump shot increases, Y points scored in a game also goes up. So there's a positive relationship between X and Y in this case. Linear regression, correlation, regression, and correlation. In this chapter, we are interested in scatter plots that show a linear pattern. If we think that the points show a linear, that means a straight line relationship, we would like to draw a line on the scatter plot. The line can be calculated through a process called linear regression. Linear means straight line, regression means going back to X and Y data to get this straight line. If X is the independent variable and Y the dependent variable, then we can use a regression line to predict Y for a given value of X. Typically, you have a set of data whose scatter plot appears to fit a straight line. Fit means all the points fall close to a straight line. This is called the line of best fit or the least square line. Computer spreadsheets, statistical software, and many calculators can quickly calculate the best fit line and create the graphs. The calculations tend to be tedious if done by hand. Instructions to use the TI-83, 83 Plus, and TI-84 Plus calculators to find the best fit line and create a scatter plot as shown at the end of this section. Remember, it is always important to plot a scatter diagram first. If the scatter plot indicates there is a linear relationship between the variables, then it is reasonable to use the best fit line to make predictions for y given x within the domain of x values in the sample data. What does it mean? It means if you're asked to predict a y for a given x, make sure that x is within the range of the given values of x. You could use the line to predict the final exam score for a student who earned a grade of 73 on the third exam. You should not use the line to predict the final exam for a student who earned a grade of 50 on the third exam, because 50 was not within the domain. That means within the range of x values in the sample data, which are between 65 and 75. 65 is the lowest point, so 50 is below it. So bottom line, do not use the regression line to predict what will be the final score when the third exam score is 50. Okay. So let's do this. Scuba divers have a maximum dive times that they cannot exceed when going to different depths. The data 12.4 show different depths with the maximum dive times given in the minutes. Use your calculator to find the least square regression line and predict the maximum dive time for 110 feet. Now, x is your depth in feet. 110 feet is outside the x values. X values goes from only 50 to 100. So never use this equation to predict the maximum dive time for x is equal to 110 because it's outside the domain of the given x values. Okay, so first thing is second, then the plus button on the bottom right corner on top of the enter button. Then number 4, clear all list, done. Then stat 1. In L1, I'm going to plug in the x values or type in the x values, 50, then 60, then 70, then 80, then 90, and then 100. Okay. Okay. Then I press the right cursor key on the top right corner, press in the y values, 80, then 55, then 45, then 35, then 25, then 22. It seems like as x increases, y decreases. Okay. So to do a scatter plot, second y equal to 1, and then you do zoom 9. And you will see it's going down the hill. As x increases, y decreases. That means there's a negative relationship between x and y. Why? Because as x increases, the depth increases, maximum dive time also decreases. Okay. What is the equation for this? So we go to stat, calc, highlight calc on the top row, then number 4, press number 4, linreg ax plus b. X list is L1, Y list is L2. Frequency list should be clear, nothing after the colon on the right of frequency list, and then you go to calculate and hit enter. Okay, so your y equal to ax plus b, a being the coefficient of x is the slope, is minus 1.114. That means negative slope. As x increases, y decreases. Your B intercept is 127.238. As mentioned previously, we will not use this equation to predict the dive time for a depth of 110 because it's outside the domain of given x. Okay. Besides looking at the scatter plot and seeing that a line seems reasonable, you can use the correlation coefficient. Co means together relation. Coefficient means a number. That is, we will calculate a number should show the strength of the relationship between x and y as another indicator besides the scatter plot of the strength and relationship between x and y. The correlation coefficient R is a numerical, is a number and provides a measure of the strength and the direction of the linear relationship between the independent variable x and the dependent variable y. N is your number. That small funny thing is Greek capital S, sigma. That means you're adding, for example, on the numerator, you're adding the sum of the products of X times Y and things like that. We are not going to use that formula. So how are we going to calculate R? Okay. First you will do, press the second button, then 0 button. And there will be a catalog screen opening up. Go down. First you have A, then B, then C, and then D. In D as in David, you should stop at diagnostic on, D-I-A-G on. D-I-A-G on. So first is the degree and all that, keep going down, day of the week, till you see diagnostic on. Align your arrow cursor to diagnostic on and hit enter. On your calculator screen, you will see no, so second and 0. And you scroll down to diagnostic on, A, B, C, D. C, D, diagnostic on. First D is day of week. You want to align the cursor or the arrow with diagnostic on, D-I-A-G on. Diagnostic on and hit enter. Okay. And you will see diagnostic on your calculator screen if you have aligned the arrow with diagnostic on and hit enter. Okay. CD, diagnostic on. And hit enter. You see diagnostic on your calculator, hit enter again. Then you calculate stat. Put your cursor on the top line on calc, which is calculation. Go down to number 4, that is press number 4. Linreg AX plus B means linear regression, AX plus B, X list is L1, Y list is L2, and you calculate. Reason you did diagnostic on, now you will see R value in the bottom of the screen. You see in this case, the previous data, it is minus 0.962. Minus sign means there is a negative relationship between X and Y. Okay. That means as X increases, Y decreases. What the value of R tells us, R is the correlation coefficient. The value of R is between -1 and +1. That is -1 less equal to or less equal to 1. The size of the correlation R indicates the strength of the linear relationship between X and Y. Values of R close to -1 or to +1 indicates a strong relationship. Here it is -0.9629, which is a strong negative linear relationship between X and Y. R is equal to 0, there is no linear relationship. If R is equal to 1, there is a perfect positive relationship. If R is -1, there is a perfect negative correlation. In both these cases, all of the original data points lie on a straight line. Of course, in real world, this will not generally happen. What the sign of R tells, in our case, we got a negative values of R means that when X increases, Y tend to decreases. And when X decreases, Y increases, negative correlation. On the other hand, if R is positive, that means as X increases, Y increases. So they said the sign of R is the same as the sign of the slope B of the best fit line. Strong correlation does not suggest that X causes Y or Y causes X. We seems that correlation does not apply causation. So the first one is R between 0 and 1. Second one, R is between -1 and 0. Third one, R is close to 0. The variable R square is called coefficient of determination and is the square of the correlation coefficient, but usually stated as a percentage rather than in decimal form. It has an interpretation in the context of the data. R square, when expressed in percent, represent the percent of variation in the variable Y that can be explained by the variation in the independent or X variable. 1 minus r square when expressed as the percentage represents the percent of variation in y that is not explained by variation in x. Okay. Testing the significance of the correlation coefficient. We perform a hypothesis test of the significance of the correlation coefficient to decide whether the linear relationship in the sample data is strong enough to use to model the relationship in population. The symbol for the population correlation coefficient is called rho. Rho is equivalent to Greek small r. Rho is the population correlation coefficient, which is unknown. R is the sample correlation coefficient, calculated from the sample data. The hypothesis test lets us decide whether the value of the population correlation coefficient rho is close to 0 or significantly differ from 0. We decide this based on the sample correlation coefficient and the sample size n. So our null hypothesis is rho equal to 0, that is the population correlation coefficient is 0. Alternate population correlation coefficient not equal to 0. Null hypothesis H0, the population correlation coefficient is not significantly different from 0. There is not a significant linear relationship correlation between X and Y in the population. Alternative, rho not equal to 0, the population correlation coefficient is significantly different from 0. There is a significant linear relationship between X and Y in the population. If R is significant and the scatter plot shows a linear trend, the line can be used to predict the values of Y for X that are within the domain of observed X values. If R is not significant, or if the scatter plot does not show a linear trend, the line should not be used for prediction. If R is significant and the scatter plot shows a linear trend, the line may not be appropriate or reliable for prediction outside the domain of observed X values. So we will use method 1, which is a p-value method. So how to do the test data with the data that we already have in our calculator? So press the stat button, highlight this time on the top row, now test, T-E-S-T-S, which is the third one. Bring the cursor, the black rectangle on top of test and hit enter. Okay. So stat, then highlight test. Actually, then you scroll down. After bringing the cursor on test, you scroll down. In the first screen that you see, you will not see this test. So you keep scrolling down till you see linear reg t test, which is F as in Frank in my calculator. You're scrolling down, your cursor on the left column is sliding down, and you go to F as in Frank, which is lin reg t test. Hit enter. So your X list is L1, Y list is L2. The fourth line is what is of interest. Remember, our null hypothesis is equal to 0, alternate, fourth line is the alternate, not equal to 0. So bring the cursor on not equal to 0 and hit enter so that it's flashing over there. We will calculate. We will get a p-value for the test statistic. What is the probability of getting a test statistic as extreme as what we have obtained? If that p-value is less than level of significance, alpha, which is usually 0.05, then we will reject the null hypothesis. In this case, the p-value is 0.002, which is less than alpha 0.05. If alpha level of significance is the maximum probability of rejecting H0 when it is true, is not given, assume it's 0.05. P-value, probability value of getting a test statistic of minus 7.14 is 0.002, which is less than 0.05. Hence, we reject the null hypothesis. If we reject the null hypothesis, we conclude that at alpha equal to 0.05, there's enough evidence to support the alternate, which is rho not equal to 0. Okay. We're not going to use the table. We are going to use in this section. Okay. Excuse me. Data are collected on the relationship between the number of hours per week practicing a musical instrument and the scores on a math test. The line of best fit is as follows. Y hat, remember, number of hours per week practicing a music, that is X, and score math test score is y prime or y hat is 72.5 plus 2.8x. What would you predict the score on a math test would be for a student who practices a musical instrument for 5 hours per week? In some data sets, there are values observed data points called outliers. Outliers are observed data points that are far from the least square line. It is possible that an outlier is a result of erroneous data. Other times, an outlier may hold valuable information about the population under study and should remain included in the data. The key is to examine carefully what causes a data point to be an outlier. So you could guess our outliers by looking at a graph of the scatter plot and best fit line. However, would like some guidelines as to how far away a plot needs to be in order to be considered an outlier. As a rule of thumb, we can flag any point that is located farther than 2 standard deviation above or below the best fit line as an outlier. The standard deviation used is the standard deviation of the residual or errors. Okay. So I'll go to the straight away. So using LinReg t-test in this data, scroll down to the output. So if you scroll down at the bottom of the LinReg t-test, you will find S. That is the standard deviation is 6.52. Okay. So 2 times 6.52 is 13. If any point is 13 above or below, then it is an outlier. If you have to measure the vertical distance from any data point to the corresponding point on the line of the best fit, and that distance is at least 2s, then we should consider the data point to be too far. So any point which is located at a distance of 13, 1, 3 in this case, 2 times standard error, which is 6.5, 2 times 6.5 is 13. If it is at 13 or below 13 from the best fit line, then it is can be considered as too far and an outlier. Okay, so outlier. So the data points on this graph from the third example are as follows. Okay, so x and y, they're given as x and y. So second plus 4, clear all list, done. Then stat 1. In L1, you are going to enter all the x values. 1, 2, 2, 3, then 4, then 4, then 5, then 6, then 7, and then 7. Okay. And so after 7, 2 sevens, then you go to top of line L2 by pressing the right cursor key. 5, I'm plotting the Y, 7, 6, 9, 12, 13, 1, 3, 18, then 19, then 12, and then 21. Now let's do a scatter plot. Remember, scatter plot is second Y equal to number 1, then zoom button, third key on the top row, and zoom 9. And it looks like the last data point, 7 and 12. 7 and 12 is an outlier. So we need to remove that and do the x and y. First of all, x is equal to 10 is not in the data set. So we cannot. We can remove the 7, 12 and redo. So let's do second plus 4. So the 1 point before the last point seems like it's the outline. So second plus 4, clear all list, stat 1. L1, we plug in the x values, 1, 2, 2, 3, 4, 4, 5, 6, and then 7. And then in L2, it's 5, 7, 6, 9, 12, 13, 18, then 19, and then 21. Okay, now let's do a scatter plot. Second y equal to 1. And then zoom 9. And now the the point before the last point, 7, 12 has been removed, and the scatter plot shows continuous going up the hill. How do you fit a straight line? So we do we do stat button, then go straight on test, stat on test. Okay, and scroll down to linrect t-test, which is F as in Frank in the calculator, and hit enter. X list is L1, Y list is L2, alternates not equal to 0 in the fourth line. Okay, then calculate. So the linear regression line is Y equal to A is the y-axis intercept is 1.035 plus 2.96x. Okay, your R value going down, you can calculate the R value. It will show you the R square and the R. R is 0.984. Okay, strong positive linear correlation. R square is 0.969. Multiply that by 100. That is 96.9% of the variation in Y can be explained by the variation in X. But I will not use this line equation to predict Y when X is 10, because X is 10 is outside the range of the given X values, or outside the domain of the given X values. So here they have X and Y values. Okay, so let's do this problem as the last problem. So second plus 4. Clear all list done. Stat 1. L1 is all the X value. 1915. 1926. 1935. 1940. 1947. 1952. 1964. 1969. 1975. 1979. 1980. 1986. 1991 and 1999. Okay. Go to the top of L2. Plug all the Y values. 10.1. 17.7. Then 13.7. Then 14.7. Then 24.1. Then 26.5. Then 31. Then 36.7. Then 49.3. Then 72.6. Then 82.4. Then 109.6. Then 130.7. and then 166.6. So we want to see how it looks. So we press the zoom button and then 9. It is not a straight line. It's going up the hill, but it is a curved pattern. So I will not fit a line through this, okay? Because there is not a straight line relationship between X and Y. From the scatter plot, we see that X increases, Y also increases, but we go up on a curved pattern, not on a straight line pattern. Bottom line, do not use this to fit a straight line. If we were to fit a straight line, then you can go back to stat, then test, and scroll down to F as in Frank, linrect t-test. X list is L1, Y list is L2, B and bit row not equal to 0, fourth line, and then calculate. A word of caution that because x and y do not fall into a straight line going up the hill, it's all on a curved pattern going up the hill. A straight line fit should not be used. However, if we were to use, then equation of the line is y equal to minus 3204.42 plus 1.662 times x. Okay. Look at the R value is 0.869. R square is 0.755. R is the correlation coefficient, strong positive correlation that is part of the picture. R square is 0.756, you might say, or 75.6% of the variation in Y can be explained by variation in X. Okay. So we will stop here today. If you have any question or comment, you can write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. If you like this video, share with your friends. If you like this video, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button at the bottom right corner. And please activate notify button so that whenever I upload a new video, you'll get a notice in the email. Thanks for watching. Have a nice day. And please check out my channel and subscribe to it, Math Science Topia, where I've solved all kinds of statistic problems. Inside the playlist, Statistics Review. Again, thanks for watching. Take care. And do not forget to come back tomorrow when I'll discuss a new problem. Thanks for watching. Bye-bye. See you next time.